Okay, so if we wanted to talk about the unit circle, we might be interested in actually labeling some of the x and y coordinates. And we'll talk about why we might want to do that in a second. But first I want to actually start with getting some of the coordinates labeled. So for example, right, remember this is the unit circle, right? And so it's centered at 0, 0 with a radius of 1. So if I wanted to label this point, right here, let me highlight it for you. So, if I wanted to label this point right here, right? The x value is 1. We've gone over 1 unit from the origin, and the y value would be 0. Okay, and we could do the same thing for this point up here, right? Pi over 2, okay, right? That one has an x coordinate of 0 and a y value of 1. And we could do the same thing over here. Sorry, I don't mean to jump around. Then this for pi, right? For that point there, we could label that point. We know that it's going to the left 1 unit, and it's not going up and down. The y coordinate must be 0. Okay. And last but not least, we go around to the bottom here. Okay. Then we know that 3 pi over 2, which is here, okay, it's going to have an x coordinate of 0 and a y value of, oops, I put positive 1, but it's going to be negative 1, right? Because it's gone down 1 unit. Okay. And for now, that doesn't really feel all that useful, okay? But let's say I actually wanted to go through and label the x and y coordinates here for this point, okay? So I'm gonna, let's say I wanted to figure out the x and y coordinates here. Okay, so we can kind of think about there being like a little triangle here, right? Something like that, okay? Now that special triangle, maybe I better label it a little bit here, and I'll do it in green so it all matches up, okay? This angle in here is the pi over 6, remember, right? That's the angle between that particular line and the positive axis, okay? And this angle here would then be pi over 3. So you might actually start to recognize this triangle as being one of those special triangles that we talked about. And so we should be able to label those side lengths, right? Now, in this case, we'd normally label this side length 2. We'd label this side length root 3, and we'd label this side length 1, okay? But instead, remember we said that this length here, right? We said that that length had to be 1 because this is the unit circle, right? And so if I needed to go through and make that be 1, I could take each of those values and divide them by 2 to make this length be 1. So this one I'm going to divide it by 2, and I'm going to take this one and divide it by 2. Okay? And so what happens here is now I've changed the side lengths a little bit, but because I've divided them all by 2, that the ratios still work. Okay. Now what I want you to notice is I want you to notice that this side length here, okay, this one here, right? That one there represents sort of the x coordinate of that point up here, right? So the x coordinate here is root 3 over 2, right? And the y coordinate, okay, is sort of, get my pen back, sorry, 1 second, right? Is sort of this side length here, right? That side length there represents the y coordinate, right? That's how much it goes sort of up and down. So 1 over 2. Now, those numbers may or may not look familiar to you, okay? But there's actually an interesting relationship going on here. Remember that if I want to work out the sine of an angle, right, I would do the opposite side over the hypotenuse side, right? Opposite over hypotenuse. And in this case, right, the opposite side, right, that would be this side here, is the y coordinate, right? Okay. So I'm going to put in y for my opposite side, okay? And my hypotenuse side, remember this side we said is always 1, right? So in this case, it's y over 1. And so you can kind of see there that sine of theta is actually just equal to y. So this y coordinate here, okay, maybe I'll do this in a different color. This y coordinate here is the sine of that angle, sine of pi over 6, right? And if I kind of do the math for cosine, right? Cosine of theta is the adjacent over the hypotenuse, which in this case, my adjacent side, that's this side here, right? That's the x coordinate, okay? So I've got x, and again, my hypotenuse side, this side here, right, is just 1. Okay. So again, I'm getting that the cosine of the angle is just the x coordinate, right? So this second coordinate here, this here, that's going to be the cosine of pi over 6. Okay. And let me just throw that here in a box so we remember that that's sort of important. Okay, so whatever the x coordinate is the cosine, whatever the y coordinate is the sine. So we could go through and use our sort of similar triangles to be able to find the x and the y coordinates here. For this one, we could draw our special triangle, or we could kind of remember, right, the cosine of pi over 4 is root 2 over 2. Okay, that comes from that special triangle, right? And the sine is also root 2 over 2. Okay. And then last but not least, if we were to go through here, right, the cosine of pi over 3, cosine of pi over 3 is 1 over 2, and the sine is root 3 over 2. Again, those come from the special angle triangles. So I could go through, I'll put a link to the video that I did those in, but that's how I'm filling out those x and y coordinates there. I do have a trick for remembering those, and I'll go through and do that at the end of the video to show you sort of how I always remember doing those. Okay, so from there, I can fill out the rest of the coordinates. So this pi over 3, right? That one is sort of directly across the circle from this point here, right? So you can kind of get the idea here that the y coordinate on this point would be the same, right? It's the same distance up and down, right? And the x coordinate, it's sort of just as far to the left and to the right, but it's to the left instead of to the right. So this is going to become minus 1/2. Okay. And we're going to do the same thing with this coordinate here, right? So for 3 pi over 4, okay, this one here, it's going to sort of follow the same pattern as this one here, except that it's going to have a negative x coordinate. So I've got negative root 2 over 2 and positive root 2 over 2. Okay. And I'm going to do the same thing with pi over 6. It's sort of related to this one here, right? And so I'm going to take its x coordinate and make it negative. So negative root 3 over 2, positive 1/2. And remember that we can use these to help us pick off the values for sine and cosine, right? So for example, right, this here must be the cosine of 3 pi over 4, right? And this one here would have to be the sine of 3 pi over 4. Okay. So we can use this unit circle to help us find those values. Okay. Now if I were to go down, let's go down into this fourth quadrant down here. Okay. And you'll notice that this point here is kind of related to this point here, right? Those are to the same distance to the right, so the x coordinates are going to be the same, but the y value is negative. Okay, so if I write in my values, we said the x value was going to be the same, but the y value is going to be negative. Okay, and by finding the sister points here for the other parts of the other points here, I would get minus root, oh no, sorry, I said the x-coordinate was the same. So root 2 over 2 and minus root 2 over 2. And last but not least, we've got, this will be positive 1/2 negative root 3 over 2. Okay. And so by sort of reflecting points, okay, from up there, we can get the new coordinates. And if we want to go all the way over here to quadrant 3, okay, this point here, right, is actually sort of similar or sister to this one here, right? They would have the same x coordinate, right? So they both have the x coordinate of minus root 3 over 2, but the y values are going to be negative, right? So if I go down here, okay, so this is going to become the point, the x value stays the same, minus root 3 over 2, okay, and then I get minus 1 over 2. And in that same sort of fashion, that's how I'm going to get the coordinates for all of these. This is going to be minus root 2 over 2, minus root 2 over 2, and last but not least, minus 1/2 minus root 3 over 2. Okay. So what I usually do is I just sort of have this first quadrant memorized, right? Everything sort of in here I have memorized. Woo, look at what it did there. That's silly. There we go. So that one I usually have memorized, and I'll post a video for the trick for how I memorize those. Okay. And then I know that I can always get the rest of them by doing sort of some reflecting and thinking about it.